Definition of a function is a relation where each member of the domain is paired with exactly one member of the range. So that means that if you have a set of points, all of the x coordinates have to be different. If you have 2 points and their x coordinates are the same, but their y coordinates are different, it's not a function. So I've listed up there a group of points that would be considered a function because all of the x's are different. That's what that little definition up there at the top says. In your language, all the x coordinates are different, is what that means. Okay? Here's an example of one that is not a function. Under that Doceri desktop trial, that point is 2, 4. That is not a function because, as you can see, 2 of the points have the same x coordinate. You see a 2, 8 and a 2, 4. Since 2 of the points have the same x coordinate, it is not a function. Now, as a graph, how do we tell if a graph is a function? Just by looking at it. We're going to use an example. The enrollment of Eureka High School from 1896 to 2016. Or whenever Eureka High School started. I'm going to show you some graphs, and I want you to tell me if it is a possible graph that would show the trend of Eureka High School's enrollment, the number of kids in the school, from 1896 to 2016. All right, here we go. Could that be a possible graph for the enrollment of Eureka High School? It could be. Possible. Okay. How about that? Yeah. Possible. Not likely that you're going to have basically the same number of students every year, but it's possible. Okay? It's possible that that could happen. How about that? Why? Why is that impossible, Spencer? It doesn't go to 2016. You can't reverse time. And in some years, we have 2 enrollments. Okay? And this is back to our definition where we have 2 enrollments for the same year. We have 2 points with the same x coordinate. So that is not a function. Same thing here. That graph is impossible to show the enrollment of Eureka High School because you have multiple points for the same year. Same thing there. There you've got all the enrollments for 1 year. That doesn't make any sense. Not a function. How about that one? Could that be the enrollment? Yeah. I mean, that's not, you assume that that's not going vertical over there on the left. I didn't draw it very astutely to show that it wasn't vertical. But that could be a function. That could be the enrollment. How about that one? No, that doesn't make any sense because you've got multiple enrollments for the same year. So there are graphs that are considered functions. In other words, they could be used as an enrollment of Eureka High School graph. And you've got graphs that are not functions because they have multiple representatives for the same year in that enrollment example. Okay, so you notice over here on the right, we have several brown dots that are lined up vertically on the same graph. When that happens, you don't have a function. Those are x coordinates that have, or those are points that have the same x coordinate. And when you have that, you don't have a function. Over on the left, every brown point that you would put on there, you cannot line up 2 brown points vertically on the graph. You can't do it. So when that's the case, it is a function. That little test is called the vertical line test. If you pass a vertical line through a graph and you can hit it twice anywhere, it's not a function. You notice I've put a black dotted vertical line up on the screen and I'm hitting that graph twice. That means that graph is not a function. On the left, if I put vertical lines up there on those graphs, I would not be able to hit those graphs twice anywhere on the graph. Not counting the arrow, of course. So there's some more vertical lines showing you that those are not functions. And there's the vertical line showing that over there, I'm only hitting the graphs once. All right. When talking about equations, we have to name our functions. And in general, the most popular name in math for a function is f. Probably for function. You can name it whatever you want. Sometimes we call them g. Sometimes we call them p. But you can name them whatever you want. You could put a whole word in there. You could draw animal. That could be the name of the function. It doesn't matter what you call it. We're going to call this function f. In the parentheses, that's the variable that's used in the equation. So f parentheses x means f is the name of our function. Okay, has a name. And x is the variable that we are using in the function. F of x is how it is said. And in this case, our function is x squared plus 2. Okay? My question is, find f of negative 3. Does anybody know what we should do to find f of negative 3? Spencer? You plug in negative 3 for x into the function and you figure out the answer. So in the function, wherever you see an x, and there might be 3 or 4 of them, or 2, in this case there's only 1, you plug in negative 3, and then you figure out what the answer is. So instead of writing x squared plus 2, we write negative 3 squared plus 2. And nobody should need a calculator for that. Negative 3 squared is negative 3 times negative 3, which is 9, plus 2. And so f of negative 3 is 11. That's the answer. In whatever the question is, find f of negative 3. You put that number in and do some arithmetic. So now I want you to find f of 2. What you should have done is put a 2 in and do a little arithmetic and get an answer of 6. Yes, sir?
F of x isn't always going to be x squared plus 2, right?
No, it's going to change every time. Here we go. H of x is negative 4x plus 7. Find h of c. So I changed the name of the function. I'm not calling this one f. I'm calling it h. I kept my variable as x. And now I want to find h of c. It's not a number that I want you to put in this time. It's a letter. It doesn't matter what I'm asking you to put in. It doesn't matter. It could be a number, like the last 2 examples. It could be a letter. It could be a wingding. It could be find h of a picture. And you put the picture in for the variable. So in this case, we're going to replace the x with a c. So the answer is negative 4c plus 7. That's the concept, is you're replacing the x with whatever you're being directed to replace it with. And you can't do anything with that because you don't know what c is, number-wise. So, like I said, whatever you're being asked to put in, you put in. Number, letter, wingding, whatever. Now I want you to find h of 3m. Same function. Okay, so you're being asked to put a 3m wherever you see an x. So we're going to take out the x and we're going to put in a 3m. So you have to do, quiet please, you have to do negative 4 times 3, and that's negative 12m plus 7.
So is that your answer?
Yep.
You don't have to solve it.
There is no solving because it's not equal to anything. It's equal to h of 3m. It's not equal to 0 or anything like that.